deal with radical expressions to add and subtract them when you have two things. Thing number one, the index number has to be the same, meaning your root has to be the same, and the radicand, so the thing under the root, also has to be the same. And then you can simplify them just like you were if they were like terms. Multiplication's a little bit easier because they don't have to have that like term component, and we'll talk about that in a minute. You just need to make sure you multiply the things that kind of go together, and I'll talk more about what that means. Okay, so look at A for the addition. The only way I can add any of those things together is if they have the same index number. Do they have the same index number? Good news. Also, I need the same thing under the root. Is it the same under the root? No, because I have a 3, and then I have a 12, and then I have 48. So then what we're going to do is see if we can kind of manipulate this a little bit so we can get some like terms. There's nothing I can do with root 3. That's as simple as it gets. Like, I can't break it apart. I can't do anything with it. But what about root 12? You can break it apart. What divides into 12 that is a perfect square? 4. So I'm going to break it into 4 times 3. And then let's head over to 48. What divides into 48 that is a perfect square? 4, bigger, 16. So if 4 works, always try to go up a notch and see if 16 works. All right, so let's simplify these. So root 3 is root 3 is root 3 is root 3. If I take the square root of 4 here, what's this going to give me? 2. So now I have 2 root 3's minus, what is this going to give me when I square root it? 4. I have 4 root 3's. So you have to think about root 3's as like a thing. So almost think of it like if you come across, story problems are always about food and like ridiculous amounts of food, right? Like if Susie has 100 oranges and Billy gives her 200 more, now she has 300 oranges, right? So think about the roots as like the things. If I have one of the things plus 2 more, how many do I have? 3 of the things minus 4, negative 1. So overall, I have negative 1 root 3's. So the root 3's are almost like a unit to me in a way, right? Like oranges or inches or feet or whatever. So you're not going to do anything with the root 3. It's just coming along for the ride. Did you say feet? Feet? Yeah. Oh. Feet, like feet. Oh. Not like feet, but like distance. Not like number of feet in the classroom. No, that's a whole... No, let's not think about feet. What?
How did you get that?
Okay.
I don't know if I like blinked and...
You may have blinked. Okay. If this is a 1, so remember you can put a 1 out front, right? 1 plus 2? 3. 3 take away 4. Oh, so negative 1. So that's what we've got out front. And you can put the 1s in. There's nothing wrong with it. It doesn't have to be there, but it's not wrong and it's not hurting anything, so that can be there. Okay? Let's do the next one. So similar goal with the next one. We're hoping that when we simplify stuff, what's under the root is going to be a match so that we can combine our like terms. Okay. I haven't done this one yet. So the other one I could see right away. This one I can't. Let's see. Does 16 go in? No. What about 4? No. Ooh, is it 9? No. 25 and 2. So you know what it is? It's 2 is going to be our number that lives underneath. Okay. You don't have to be there with me right now. Okay, ready? Okay. If you play the game and you keep dividing stuff in, I was looking for even numbers. I was headed the wrong way, though. What actually divides in, that's a perfect square, is 49. Yeah. So you'd have to keep trying them. And you could even make a list. Could you make a list off to the side of all the perfect squares and start trying them one at a time? One of them's gonna work. So this is going to be 49 times 2 minus. Now, I'm going to kind of cheat off this answer. Do you see how there was a 2 under the root? And that's going to have to stay. So that means there's going to be a 2 under this one too. So that means this one has to be 16. Plus 3, 25 times 2. So let's say 98, that was actually the trickiest one for me to come up with. Could I have started with one of these other ones and then worked over?
So as soon as you figure out that like one of them would be times 2, you just know all the other ones.
Have to be 2 so you can add them together. So you need that commonality of it having a 2. Yeah, you need the same radicand so you can add them up. And your book's going to give you problems because like this is its goal, right, is for you to practice this skill. So it's going to have problems where it's going to be a matching radicand. So again, if you start with 1 and you're like, I don't know, then try a different one and see what that number is and kind of cheat off of that and use it for the other ones. Okay, here's a little bit of a trick though. When I go to square root the 49, what is it? 7. So there's the 7 that's coming out front, but do you see how there's already a 2 there? The 7 and the 2 get multiplied. Because the 2's just sitting there. It's not being added, right? It's being multiplied. So 2 times 7 is, so I have 14 roots of 2. Minus, this one's not tricky because there's nothing out front. What's this one? 4 roots of 2. Do you see how, though, you really are multiplying, right? Because if a 4 comes out front, 4 times 1 is 4. So we were doing it without realizing what we were doing, probably. All right, this one, what's going to come out front with the 3? 5. 5 times 3 is? 15. So I have 15 root 2's. Okay, so again, think of the root 2's as things. Oranges, apples, bananas. Somebody gives you 14 oranges. Then they take 4 away. How many oranges do I have now? 10. And then they give you 15 more. How many oranges? 25. You have lots of oranges, lots of vitamin C. And again, in place of oranges, it's really a root 2, right? The root 2 is your thing. It's the quantity, like you have different quantities of it being added or subtracted together. How are we doing with those? Okay? Okay. A and B are going to kind of give you more practice on what we were doing on Friday, but with a little bit of a trick. The tricks? Yeah. Okay, do you see how we have multiple things being multiplied? Yes. Let's condense it down into a single thing first. So that's the trick. And then they'll look just like the problems you had on the homework. Do you see how these things are both out front things? So those get multiplied together. 2 times 5 is 10. So that's where this 10 came from. Under the root, we're going to have these things, but we need to multiply them together. So let's multiply. 3 times 12.
36.
Yes. Remember when we multiply, we add exponents. So here's an a to the first and an a to the third. I have a to the fourth. And then I just have a b. The b doesn't have a buddy. There's nothing to multiply to it. Now, does this look like a problem from Friday? Maybe minus the 10 out. Yeah. If the 10 wasn't there, let me cover that up. Does that look like a problem from Friday? Yeah. So there's not much difference here. So let's break it apart just like we were doing on Friday. 36 is already a perfect square. Love it. A to the fourth is already a perfect square. I don't know why I'm even rewriting it like this. Is b a perfect square? No, and it's going to have to stay underneath. I don't know why I rewrote it. There was no benefit to that. All right, let's start moving stuff out front. Let's start with the 36. What's going to come out front from that? 6. It gets multiplied by the 10 that's already there, so I have 60. If I square root my a to the fourth, what comes out front? A squared. And then the square root of b. Can I square root that? No. So it lives on underneath. So again, similar to Friday, but extra tricks. Trick number 1, condense it into one thing. Trick number 2, you're probably going to have a number out front that you're going to have to multiply by. All right, let's try part B. Very similar to A. 4 times 2? 8. So that's my out front thing. 7 times 21, I don't even know. 147. And then we have x to the y to the second. Okay. All right, let's see what 147 is divisible by. Hi, good morning. Oh, it's not 9, people. Spoiler alert. What? It's cold? I feel like it's... I was going to say, I had my space heater on, but I've already turned it off. Yeah, it feels pretty good. Also, would you email... Can you hear my heater? Yeah, it didn't used to before today. Would you? Okay. I just always feel bad emailing because I feel like people have bigger problems than my heater sounds a little sick. Okay, that's true. That's true. That's true. Good point. Good point. I just always feel bad because I'm like, it's not really a problem. It could be. Yeah.
Mr. Sass's is bad. It's like,
We had had last week, like, a couple times because it was so cold in the room.
he just told us.
Okay, so maybe I should say something in case that's where we're headed. Got it.
He was like, at one point he goes, just bring your winter coats, guys, it's not getting fixed.
Yeah, he was like, this isn't gonna get fixed until you're all graduated.
I love.
He goes, if you want it fixed, have your parents email.
Okay. Here we go. All right, while we were discussing with Miss Livingston, I was trying perfect squares, and I used the one that, remember the one from earlier that I was like, what goes in there? 49. 49 times 3. I know. All right, what do we know the square root of 49 is? 7. So that 7's going to come out front and get multiplied to the 8, which is 56. Okay, the 3 is going to stay under. Unfortunately, I can't take the square root of 3 and have it be something nice. If I square root the x to the 6th, what do I get? X cubed. If I square root y squared, I get y. So the only thing that we had remaining underneath was the 3. And again, at one point we were like highlighting stuff. If that helps you, you can continue to do that. All right, so it's a little bit trickier, but it allowed us to practice it again. So I think for that reason, I like that. Okay, ready? All right, let's continue onward. These were the ones that we didn't love, but we already kind of saw a little bit of it on Friday. We're going to do A last. Do you see how I wrote myself a note? I was worried I would forget. Do A last. When you get older, you'll realize this. You'll be like, I need to write myself notes because I don't remember. Same. Wow, you already do that? Perfect. Look at that skill. All right. I'm going to break this apart, and I'm going to take the square root of the top. Can I do much with that? Well, I can do something with the x's, right? All right, and I'm going to take the square root of the bottom. So I'm going to think of them as two separate square roots. All right, the root 6, nothing I can do. Is 5 nicely divisible by 2? Drop down to 4. Is 4 nicely divisible by 2? Yes. So let's go 4 times 1 in terms of the powers. In the bottom, 4 is a perfect square root, yeah? Is 3 nicely divisible by 2? Drop down. Is 2 nicely divisible by 2? So let's do y2 times y to the first. All right. In the numerator, the only thing I can square root is this x to the 4th. 4 divided by 2 is 2. So under the root, I still have this 6 and I still have this x. And again, remember I was highlighting stuff that I couldn't square root. If that helped you, you can keep that up. And then if I'm looking at the denominator, this is the one I can't square root. Okay, let's worry about the denominator. It's almost like they're two separate problems for right now. What's the square root of 4? 2. Square root of y squared. And then the y lives underneath. Okay, Do you remember what the math police don't like?
A root under.
Any root under, in the bottom, in the denominator. Do you remember what the fix is if there's just a square root?
Just pretend it's not there.
Close your eyes, pretend it's not there, and move on with your day. Yes, avoidance. Okay. All right. The real trick, yes, that is one thing you could do, but it's not the right answer. The right answer is to multiply it by itself. So if you have a square root in the denominator, and we wrote this in our notes on Friday, so if you flip back, it's in there. If you have a square root in the denominator, you multiply it by itself. All right, I'm still going to do 2 steps to finish this one off. All right, so do you see how the x squared is out front? Stays out front. Under the square root, I had 6x, and now it gets a buddy. It gets y. Y is joining the fun. In the bottom, I have 2y out front. Y times y is going to give me what under the root? Y squared. Okay. Can I square root y squared? Yeah. I got to keep going because I got to get rid of the root, remember? That's the dream. If I square root y squared, what is the square root of y squared? So instead of having this, I'm really just multiplying by y. So my final answer is x squared times the square root of 6xy all over 2y squared. Not the nicest of answers, is it? It's kind of a bummer. Okay, so I'm going to draw kind of some boundary lines in so we can see where stuff is. It's not. It's not. It's kind of going back and doing kind of the same thing over again. Like our problems on the homework today will just be trickier because they really will be problems where you have to deal with roots in the denominator. Yes. Good stuff. Okay. All right, let's break apart C. First of all, can I cube root 7? Bummer. Can I cube root x cubed? Yes. What is the cubed root of x cubed? X. Okay, so the x comes out front. Here's my cubed root. Here's my 7. Can I cube root y? Yeah, I can move it up. Sorry. No. So the cube root of y stays in the denominator. I heard whoa, whoa, whoa. So let's, whoa. Cubed root of 7. Can I take that? No. So there it is. The cubed root of x cubed is x to the first. So the x came out front, the 7 stayed underneath. Can I cube root y? No. So we're just thinking of it as cube rooting the top and bottom separately. Okay. I'm going to write this as y to the first because that's going to help me in a second. So if I use the same trick and I just multiply it by the cubed root of y, I'll get the cubed root of y squared. Does that do me any good? No. I need this number to match this number because then they're going to undo each other. So I need to multiply by the cubed root of y to what power? If I did 3, this would add to 4. So we need 2. So again, we want the number underneath to match the index number. Remember, when you multiply, you add. If I do something to the bottom, I have to also, yeah, it goes to the top too. Okay, so in the top, I have my x, I have my cubed root. What lives under my cubed root in the numerator? 7y squared. Yep, all the things that were under there are still under there. In the bottom, what's this going to become? The cubed root of y cubed. Well, what is the cubed root of y cubed? Y. You have to rationalize the denominator. And what's funny is then, if depending on what grade you're in and where you're going to end up in your math journey, some of you might join me in pre-calc, where we're going to talk about the fact that sometimes, instead of rationalizing the denominator, it actually helps to rationalize the numerator when you're trying to find derivatives. So if you join me again in a couple years for pre-calc, we'll have a different discussion about rationalizing the numerator, which is the same process. You should. Join me. Okay, you ready for A? Ooh. Oh, you need this one still? Yeah, that's my final answer.
I feel like I can do these and then I get to the homework and I'm like,
Well, that's why we practice. And I showed the kids, I'll have to show you guys the same video I showed the kids in my first hour. I'll show you at the end though when I'm done recording. It's not a bad video, but it's a little short one. I think it's cute. It made me smile. Oh, just a little video I found online.
Wait, Miss Bessel, do you teach personal finance?
No.
College algebra?
No.
What? You don't teach
But just because I don't teach them right now doesn't mean I never will. Yeah.
All the math teachers
Who's teaching college?
Yeah. No idea. Yeah, I have no say. All right, here we go. What do you notice is different about part A, and maybe why I said, ooh, do this one last?
because it doesn't look nice.
It doesn't look nice, but also, like, what's going on in the denominator? Like, we've had roots in the bottom.
It's not nice.
You just can't do anything.
Do you see how I have two terms?
Yeah.
That's the issue. Okay, so we are going to multiply by what's called the conjugate. So if you have two terms, we multiply by the conjugate. Conjugate.
Are you just making up words?
No. I wish that I was making up words. I was talking to my son the other day about snow days, and I was like, you've got to flush ice cubes down the toilet and sleep with a spoon under your pillow. And he's like, are you just saying stuff to try to get me to do something to like see if I'll do it? Yeah, isn't that another urban legend? Spoon under your pillow.
Inside out and backwards.
Thank you. I told him all those things though, and he's like, he's looking at me and he's like, are you just? He's like, is this a game where you're like trying to see if you can? Yeah. Anyways, but he thought I was messing with him and just trying to get him to do these things. Anyway, which is fair. I could see myself doing that. So no, I'm not making up words. Conjugate is actually a word. This kind of reminded me of that same thing. Conjugate is a word. Putting your spoon under your pillow, yes, mid.
I don't think it is.
But maybe it's not. Okay.
I think we should.
All right. Here we go. Look at your denominator. The conjugate sounds like it's going to be something big and confusing because it's a word that we maybe have never heard before. All you do is you multiply by the exact same thing, but you switch this sign. Remember, like difference of squares, how stuff cancels out when the signs are opposite? That's how it's going to help us.
This is wild.
So if we multiply that to the bottom, we also have to multiply it to the top. Wild. Okay, let's deal with the top first. 5x times 2 is what? 5x times negative root 3 is just going to be negative 5x root 3. It's not going to join the 3 under the root because it wasn't under a root initially. If it had been, then they would join. Okay, so that's what I have for starters. Let's FOIL the bottom. What's 2 times 2?
4.
What's 2 times negative root 3? Negative 2 root 3. This is going to give me a positive 2 root 3. What's going to happen to those?
Oh, they might, cancel out.
Not might. They will. They surely will. That is their destiny. Positive times a negative is a negative. Root 3 times root 3 is root 9. Okay, hold on. Positive times a negative is a negative. Root 3 times root 3 is root 9. Okay, in the numerator, I have 10x minus 5x root 3. In the bottom, these cancel. This is going to be 4 take away what? 3. Well, what is 4 take away 3? And what is anything divided by 1? Just itself. I don't know. I was going to put another 10 there. Don't write another And that's your final answer. That doesn't always happen, by the way, that it's 1. That was a coincidence for this one. That was kind of a nice coincidence. If it had been, let's say it had been 5, could I simplify with all the 5s? Because they're all divisible. Yeah. So you're going to have to look out for those and see what you can do to simplify.
Would you not, do 10x minus 5x and get?
I can't because one has a root 3 with it. It's got this bonus root 3 that this one doesn't have. Could I factor out a 5? I could. I could have 5 out front times the parenthesis 2x minus root 3. So I could factor something out, but that's, you know, we've already done a lot. I don't feel like that's part of our journey. Okay, also speaking about snow, do you know the good news about Wednesday? It says, like, the max right now is 11 inches of snow, guys.
I saw you look.
Right, because it's Wednesday night, so we might get a 5-day weekend. Right? Okay. See, I had to wait and say, I was going to say that when I was talking about the spoon, but then I was like, no, I'm going to lose them completely. Okay, homework, 339 to 340, numbers, 11 to 14, 17 to 19, 29 to 33. All the ones that I just gave you.
Are you sure?
I am.